Okay, so this is 22D, covalent bonding, checking drawings. Your goal here is to determine if the covalent bond is drawn correctly. We have done this in the past, but then after like the last 3 days of drawings, I figured that, maybe recapping, taking a step back, and then hopefully things make sense in our mind a bit more. So, on to how we do this. So, how to check if a covalent bond model is correct. This is what I have. The covalent bond, the compound is O3, which is ozone. The little 3 means that there's 3 oxygens. And so I have steps on here. So the first step, we follow them in order because first goes first. So first step is the total valence electrons. Normally, we're like, okay, we have O3, we go to the periodic table, we find the column, all that stuff. But I made this easier for us. And the picture to the right has the valence electrons already drawn. So we have our 3 O's, and there are 6 valence electrons around each, so we just need to add that up. So there are 18 valence electrons. So that's that. Second is to compare the total electrons. And then it says total valence electrons in bond model above. So this is my bond model here. I need to count the number of electrons. Remember, each dot is 1 valence electron, and each line is a bond, and that is 2 valence electrons. So in total here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 valence electrons that are drawn in this model. Next, it says compare with the total valence electrons. Notice highlighted in yellow, that means it's this number, highlighted in yellow. So does the model agree? The answer is yes. It's 18 and 18. These are like matching numbers, right? They compare, they are the same. So we are filling this in with a green. Green means go, green is good. So if yes, green is yes, you need to still check the octet rule. So far, is this image good? Is this drawing correct? Yes, but we need to check the octet rule still. So this is our third rule. Third, check the octet. You need to count the number of electrons that are around each of the atoms. So the O on the left has 1, 2, 3, 4, 5, 6, and the single bond. People forget that, which is 2. So it's 7, 8. So there are 8 that are surrounding the oxygen on the left. Next is the oxygen in the middle. You have the 1, 2 up top, but it is also has 2 different single bonds connected to it. So there is a single bond over here and a single bond over here. So that means each bond is 2 valence electrons. So it's 1, 2, 3, 4, 5, 6 valence electrons surrounding that O. And then over here, this oxygen has 8 surrounding it as well. So for checking the octet rule, the question is, does each atom have 8 electrons? The answer is no, because the middle one here only has 6. So this right away can be highlighted, filled in red. So is this covalent bond model correct? The answer is no. Why? Because the model does not follow the octet rule. The middle oxygen only has 6 valence electrons, right? That's our mistake. That's our problem. So that's why this drawing is wrong. So that is that. Okay, moving on to slide 3. So this is the next example here. We have how to check if the covalent bond model is correct. So same thing. Again, we have O3, right? This is like the same thing. You're like, Sunday, you duplicated the slide. No, I did not. The image is different. So this picture is different than this picture. Okay, so again, we're trying to see, is this image correct of this compound? So first things first is the total valence electrons. It's still 18 because it's still O3. I have 3 O's, 6 valence electrons in each. 6 plus 6 plus 6 gives me 18. Next is I need to count how many valence electrons are drawn on this thing. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 valence electrons drawn. So now we need to compare the total valence electrons, and does the models agree? So we have 18 up here, and we have 20 down here. So those do not agree, so we fill this in as red. At that point, what we do is stop. We stop because the model is wrong. So you're done. You do not need to keep going on to the third step. So The model is wrong. So is this model correct? No. And then because the number of valence electrons drawn does not match the number of valence electrons from above. And if you want to include the numbers, so above there should be 18, and then the drawn one is 20. And so you don't even need to go on to the third part checking that set rule because it's already wrong. So there's no point in continuing because you don't have the right number drawn. So that is that one. Okay, next one. Here we are. So again, it's still 03. This is just a different drawing of it. Okay, again, the goal is for we need to figure out how is this correct. So total valence electrons is still 18. Right, I have these over here. I just add up all of them from over there. Next, second, compare my total electrons. So I need to count the number in this image. Each single bond is 2. So each single bond is 2. And then over here we have a double bond, so that's 4. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So do these match? Yes. These match, so this gets colored green. And then I need to check the octet rule. I'm not done. I can't say this is correct because I still need to check octet. So third, check octet. Surrounding this oxygen, I have 8. Don't skip the single bonds, right? It's not just 6. This is included in that oxygen. And then in the middle oxygen, I also have 8. Again, the bonds are included. So since it's touching this bond and this bond and this bond, that's 6 electrons, and then 7, 8 from up top. And over here, I have 8 as well. The 4 from the pairs, and then 4 from the bonds. So is this good? Yes, this gets a green. Love that. And so is this covalent bond model correct? Yes. And explain your reasoning. Because the number of valence electrons drawn matches the number of valence electrons, and the octet rule is satisfied. So if both of these are green, you're good. The model is correct. If one of them is red, it is wrong. And then the other side note, just to keep in mind, is within the octet rule, yes, everything wants 8 except for hydrogen, which only wants 2. So in one of these examples that you guys are going to be doing, you're going to have hydrogen. An octet is still followed if it only has 2. In fact, it only needs 2. So just keep that in mind. And that is it. The rest of them, this says now you do it. Recheck what we did together if you have questions. So there's a bunch of these. This is due on Monday at midnight.